the project here under assignments, and I'm going to go through the whole thing, even though we had started some of it before, and I'll just go kind of quickly over what I've already covered, but just as a review. And then for those of you that may have missed it, you'll have the full project. But this is project 1, which is right here. And it's called You Are What You Eat. So let me go ahead and bring that up. And I will be stopping the recording here and there for the live students in case they have any questions for me. And of course, the tape will only roll through my instructional parts. But if I have to have you work, or if you have additional questions, I'm going to go ahead and stop the recording. But basically, this is a project here, which we had already started looking at. It says calories are a unit of energy. You may burn around 70 calories just sitting at your desk, and over 100 calories while you sleep. The energy required to lift a book from the floor to the table is 3/1000ths of a calorie. The table to the right shows the grams of fat and the calories for 11 hamburgers from 3 different fast food places. How many hamburgers do you eat each week? Obviously, you don't have to answer that question. And some of these pieces of information are interesting, but not necessarily important to our project. It says, look at the data. What do you think is the relationship between the grams of fat and the calories in a hamburger? Is it a positive or negative association? This will become more clear when we actually plot the data. But I think what should be fairly clear is that as you're increasing in the fat grams, the calories are also increasing. So I think most of you would have been able to answer that this is a positive association. As the fat grams increase, the calories increase. Are there any questions about that?
No.
Okay. The second question says, in order to graph the data and set up an appropriate viewing window, consider the following. What is the independent variable? What is the domain? So the independent variable is related to the domain. The independent variable are the number of grams of fat. It is the input piece on the left-hand side. And if you wanted to have something to write there, let me go ahead and see if I can download this document. I guess I did. Let me open it where I can actually write on the document, because when it's opened up on my Chromebook, I cannot make notes on it. Let me see if I can find it on here. Let me try to download it one more time so that I could see where it got stored. Even though I've downloaded it a number of times, it is in my, okay, let's put it in downloads. Okay, hopefully I can find it and share it with you. Let me first find it. Okay, good. I'm gonna open it so that I can actually potentially annotate it. Now let me just share the right thing with you. Okay, all right, so here it is. All right, so I don't know if this is gonna allow me to write. Okay. All right, so what I want to notice here is that I start with a 9 here and I end with a 79. And so what I actually want to maybe do in terms of the independent variable and domain, you'll say the independent variable is the number of fat grams. And rather than start with 9 and go up to 79, why don't we go from, say, 0, which is a little bit lower than 9, um, and go all the way to, somebody suggested, if it's going to 79, you know, I think it'd be okay if we go all the way to 100. So let's go ahead and use that as our input output. So my audio went out at some point, evidently, right? And I'm not sure how much you missed, unfortunately. I'll try to clean that up on the recording. But what I was trying to get us to do was to choose 2 points, 19 and 360 and 49, 720. And label those as x1, y1, x2, y2. And then to use the slope formula, which is m is equal to y2 minus y1 over x2 minus x1 to come up with some kind of estimate for the slope. So I'm going to pause the recording for just a second and let everybody catch up to where we are now. All right, so then for me, if I were to do this with the data, let's see what I would end up with. I'm doing this on a calculator, and I'm not sharing that calculator with you because I'm simply gonna do 720 minus 360, 720 minus 360, and that gives me 360. So that's gonna be the numerator. Unfortunately, this thing kind of grays out whenever I write. So it may be a little harder to see. And then the bottom is going to be 49 minus 19, which I don't need the calculator for that. 49 minus 19 is 30. And with some pretty easy math, you'll see you get a 12, which is actually going to turn out to be a pretty nice estimate. You might have gotten something different. You might have gotten something like 11. You may have gotten even something like 9. But basically, and you're going to answer this question later, but basically what we're saying is that every time you increase by 1 gram of fat, so every 1 gram of fat is going to translate into 12 calories. And you want to write that in words, but that's an important point, and it's going to come up in a little bit. All right, now the next thing, it says plot the calories versus grams of fat as a scatter plot, and then find the line of best fit. So let's go ahead and do that. Let me share. I have a different thing I'm going to use over here, and let's see if I can get it into this calculator that I can share with you. This is my online calculator. So let's see if I can get in here. Okay, good. Let me go ahead and sign in. All right, so I'm signed in. All right, so you should be seeing my calculator. Is that correct?
Yes.
Okay, great. So what I'm going to do is I'm going to put the data in here. Okay, and this is the data from that PDF. Let me go ahead and find it. All right, so sorry, I have to kind of open 2 screens, and it's a little bit challenging. Let me see. 11, enter. No, it didn't enter. Let me try that again. I have to find a way to look at the data and also input it in the calculator. And I may just have to have my 2 computers open. All right, so it's 11, enter, 9, enter, 19, enter, 24, 28, 4, 28, 35, 38, 43, 49, 53, 49, 53, 79. All right, now I'm gonna go over to the other column, and I've got 270, 270, 360, 400, 450, 570, 620, 660, 720, 790, 720, 790, and 1060. Okay, so everything should line up if I didn't make any mistakes. It all looks good to me. And going back to the prompt, let's see what they want us to do. So it says, plot the calories versus grams of fat as a scatter plot, and then find a line of best fit. Okay, so so they kind of tell us how to do it and enter the data. We did all this part. And before we find the line of best fit, they want us to answer. We're supposed to plot the data as a scatter plot. We'll look at it here in a minute. And then it says, how does your answer for question 3 relate to the graph? Okay, so question 3 was the slope, and let's look at the graph together. By the way, and I think this is in the instructions there as well, we want to set the window so that we can see the full picture. So do you all remember what I put in for domain?
0 to 200.
So I'm going to use a 0, I'm going to use a 200 here.
Oh, my bad. It's 100.
100.
Okay, perfect. So we'll just adjust that. 100. Thank you, both of you. And it might be worth going by tens just so that we could see the tick marks. And what was the range?
200 to 1200.
And that's a way to capture the data on our graph. Okay. We also need to turn the plot on. Notice that it is off. So we want to make sure that it's on. And now we can look at the graph. And there we go. We have our data. And the question for number 4 was, what is the relationship between the graph and your answer to number 3? And I'm just gonna pause for a second while I try to get some answer. Okay, so by now you should have a rough answer to question number 4 that relates the number you got in number 3 and maybe even linked up with your answer to question number 1, and then how all that's connected to what we're looking at. All right, let's go ahead and look at the next question on the PDF, which says, let's see if I can. Having trouble scrolling down for some reason. And it may be because I zoomed in, so. Okay, we'll go to the second page. All right, so it says, all right, so it says now, it says to create your own line of best fit, press stat, arrow over to choose calc, And up arrow to select manual fit. All right, then arrow down to select calculate. Your equation will automatically be stored in Y1. All right, so what are they telling us to do? They're telling us, oh, and then there's more instructions here. Move the cursor along the line, along to where the line of best fit appears to be. Press enter, then move the cursor again and pick another point. I think it's better if I just show you what they're describing to you, which is this, right? It said go to stat, calc, and then it said manual fit. And it says it'll automatically be stored in Y1. I guess it will, but because it's asking me to input something here, maybe, I don't know, we should just trust it, or maybe I should tell it where I want the equation stored. I think that would be smarter. So I'm gonna go to stat. No, my bad. It's in, let's try that again. It may automatically store it, but I don't want to chance it. So I'm going to go to vars, yvars, enter, enter. And what it wants me to do is you kind of have to pick up, you know, where you want the start to be. I don't know. I'm going to pick something kind of off just to illustrate. Okay, so now it wants to put a line, and because of what I did, it's gonna be hard for me to match. And I press enter, and that's kind of far off, right? So what it wants me to do is to adjust the slope, which is up here, and the y-intercept. So I don't know, maybe my slope appears to be too steep. So let me use like a 14 maybe. That looks a little better. And then, but it's too low, right? So maybe I want to move this up. Maybe I want to move this. That looks like a minus. So maybe I want to make it a plus, plus 100. Oh, let me see something. I should use a plus sign. Oh, maybe I don't need to put a plus. Okay, so that's decent. It's not great, but I'm gonna say I'm happy with it. Okay, so 14x plus 100. And it's also stored over here. Okay, so it's not the greatest line of best fit, but let's just say for now that it's gonna do. You might have done a better job. Okay, so what is your equation of your line, and explain the meaning of your slope? So my line was y equal to 14x. I think I chose 100. And you have to try to explain what is the meaning of your slope. Of course, you know that this here is a slope, and we kind of already talked about what the slope does. It tells us something about calories and fat. So I'm going to stop the recording and let you try to answer that part of the question. All right, so by now you should have some kind of answer that relates the number you chose as your slope to the data, the dependent variable and the independent variable. All right, now on number 6, it says, how does your equation compare with the linear regression, which we haven't done yet? Their instructions are a little bit backwards here, because they should have actually said, you know, run a linear regression first. So they put the instructions backward in my view. Let's go ahead and run a stat calc lin reg and let's store it in Y2. And then we'll be able to answer how does your equation compare with a linear regression and view them together. So all their instructions here are backwards from how we should be doing things. What they're asking us to do is to do this stat calc linear regression. Now we want to store the regression equation in Y2 so that we can view them together and then calculate and look at the equation you get in this case, 11.789, etc., and 145.07, etc. Now, there's too many decimals, so why don't I go ahead and simplify this and just say, gosh, that's just like 11.8, right? So that's good enough. And 145.07, that's just 145.1. Let's make our life easier and less complicated. And that's good enough because when we look at the graph, it's going to be pretty obvious that the red equation is better than the blue. So you should be able to answer now the question, how does your regression equation compare? How does your equation compare with linear regression? Okay, so you should have been able to compare the two. And let's look at the last set of questions here. So now we're just going to use a linear regression for this part. So it says use the regression equation to answer the following questions. What does the y-intercept mean in terms of the number of hamburgers? Well, I was surprised when I read it today that it said that it had to do with the number of hamburgers, because actually maybe a better question would have been, what does the y-intercept mean in terms of the number of calories? So we're gonna adjust the question and ask this about calories, not hamburgers. I suppose there's a relationship there, but here's my thinking on this that'll help us understand what y-intercept is. So if I go back to the graph, and I'm gonna get rid of the manual fit one. I can just turn it off. And I'm gonna go over here and I'm gonna say, look, well, let's try to figure out what the y-intercept is. And let's suppose that I, have a hamburger that's got like, I don't know, 25 grams of fat. Gosh, that's gonna have 440 calories, right? All right, so we're trying to get at what this question is asking. All right, well, what if then I eat a hamburger? Let's say I've got some lean beef there, and let's say it's only got 10 grams of fat. Well, that's a much healthier burger with less calories. And then so what if I go what if I go to, can you imagine a burger with no fat in it? I don't know, maybe it's a veggie burger or something, or maybe there's no meat in it or something. Well, I'm still getting 145 145 calories. And then you'll say, well, that 145.1, isn't that part of the equation over here? What do we call this thing? Well, yeah, that's the y-intercept. Okay, so given some of that explanation that I gave you, I'll let you come up with an answer for all right, so for the next question, it says how many calories are in a hamburger with 22 grams of fat? Well, you saw me do some guessing. You know, using the blank screen, I could use that bars, y bars, enter, and make sure you pick the right equation. Now, I think it said 22. I'm going to let you do this one on your own. I'm just going to do a couple more. Gosh, let's suppose I have a burger with 60 grams of fat. Wow, that's going to be 853 calories. And you could do, whatever you wanted to predict. Let's say 5 grams of fat, and so on. Another way you could do this, let me use the same numbers, 60 and 5. You can do it off of the graph and hit trace, and go 60, enter. Then it gives you the answer. And then maybe you do 5, enter. And that gives you the same answers via the graph. You can also go to the table and let's go down to 60. So you get 853, and then 5 is back up where we were. Okay, 204. And so based on those examples that I just gave you, you should be able to answer question number 8. Okay, so the final thing is number 9. And actually, before I go to number 9, let me go at number 8 in a different way. We could have simply, and I'm going to use the 5 and the 60. I think this was an, gosh, 11 point, what was the equation there? Let me see if I remember what it was. It was 11.8, 11.8, and 145.1. So I'm going to plug in a 5. So here's yet another way of doing this. Okay, and then you would solve that and get your answer. And of course, you could do that with, you could replace a 5 with 60 or with 22. And the reason I wanted to do that is because I wanted to remind you that we do have this equation that we're working with, y equals 11.8 x plus b, and that you can use this to answer the next question, which is if you've got 1243 calories, how many grams of fat are there? You just have to know that you plug this in to the right place and then solve for x. Okay, and that's because, so I've got 1243. You might want to use the equation. Let's see how we would use the graph. Let me see if I could find the graph. Okay, there it is. Because to find, what is it, 1243, by say tracing, that's not gonna be as easy. Let me see if I can get to 1243. That's 1244, which is pretty good, and you could certainly use that as your answer. You can use a table maybe and look for 1243 in the table. That means I have to go pretty far down. And you get to 1242.5. That's also extremely close. That might be good enough for you. But the other way to do it is with the equation. All right, so I've basically run you through the whole project. Hopefully that'll give you enough instructions to finish this off or go through it again on your own. And please send me any questions that you have.